Okay, we're going to be going over a problem from the Practice and Skills workbook. It's page 101, problem number 5. List all number sets that apply to each number, and the problem that has 0.3 with a repeating bar over the 3. Okay, so what we're trying to do on this one is we're trying to think about the different types of sets that we have. For example, like whole numbers, integers. We also think about words like rational, whether or not something's rational or not, real numbers, irrational, something's not going to be rational. And let's see, we got integers, whole numbers. You could go ahead and say counting numbers. So there's a whole bunch of number sets. There's more of them, but for right now we can just go ahead and go off those. Okay, so we're just going to go ahead and check each of these. Whole numbers, so we're going to check to see if it belongs to the whole numbers. Now remember, the whole numbers are the ones that start at 0, and then they just go ahead and they just count up by 1. So if I look at those numbers right there, 0.3 with the bar over, it's not going to fit in there. Now integers, remember, are the numbers that are negative and positive whole numbers. So negative and positive whole numbers, and then counting up, and it just continues on and it actually goes back in this direction. If we go ahead and we take a look, this number right here, this 0.3 with the bar over it, will not go, it won't fit into any of those. Okay, and since we have integers, it's probably easier if I go down to the counting numbers. Counting numbers start at 1 and go 2, 3, 4, and just keep on going up by 1. The only difference between a whole number and a counting number is where it starts. Whole numbers start at 0, counting numbers start at 1. Okay, so I'm going to go ahead, I'll go over to the next one, which is rational. Now rational, we have to show 3 things. We've got to show, can we make this into a fraction? Okay, and we've gone over this in class. One way to make this into a fraction real quick is if it has one number under the repeating bar, one digit, we take that number, we write that number down, and we put it over 9. And we've explained in class why we put it over that 9, so I won't go through that explanation, but put it over the 9, and then we can just simplify that down and we get a 1/3. Okay, so if we look at rational, we have to show 3 things. One item we have to show is, can you make it into a fraction? Well, I just showed that by making it into a fraction. Okay, so that's like the first thing. Second thing is the numerator and denominator, are they both integers? Yeah, they're both integers. We have a 1 up here, and that's an integer. We can look at our integer set, and we have a 3, and that would also fit in there. Okay, so I'm going to say are integers. So that's a good thing. And then the last thing is an easy check. The denominator can't be equal to 0. So I look down here, it's a 3, it's not 0. Now all 3 of those are true, so we go ahead and we circle this one. So it is going to be a rational number. Okay, our next one is our real numbers. If we go ahead and take a look at the book, on the Venn diagram that's in the book, it'll obviously tell you that any rational number is going to be part of the real numbers. So if a number is rational, then it'll also be real. So I'll circle that one. And if a number is rational, there's no way it can be irrational. You can't have happen at the same time. So it's not going to be irrational. So the only 2 numbers on this one would be the rational and the real numbers. And those are your answers.